767 fire protection is provided by fire and overheat detection systems that provide alerts to the flight crew and operate fire extinguishing systems that provide a means to extinguish a fire. The 767 uses several different systems to detect overheat, fire, and smoke. These include fire and overheat detector loops for the engines, APU and wheel wells, smoke detectors for the lavatories and cargo compartments, and temperature sensors for pneumatic duct leak detection. The detection systems for the engines and APU continuously monitor themselves for faults and automatically take corrective action when a system failure is detected. The battery bus supplies electrical power for the fire detection and for fire warning. The hot battery bus supplies electrical power for the fire extinguishing systems. Overheat detection is provided for the engines. Fire detection is provided for the engines, APU, and main wheel wells. Smoke detection circuits provide the fire detection capability for the cargo compartments and lavatories. The pneumatic system is equipped with temperature sensors that provide overheat detection if they detect a hot air leak from the wing and body pneumatic ducts. Fire warnings and engine overheat cautions are displayed on these panels in the cockpit. APU fire warnings are also provided by lights and a horn in the nose gear strut. Fire system test switches are installed on the aft control stand. A system fail switch light illuminates if a dual loop failure exists. Pressing the switch resets the system for monitoring of other fire detection systems. Okay, we have provided a simple introduction for the fire and overheat detection systems. Now let's introduce the methods of fire extinguishing. There are 2 agent bottles installed on the aircraft for use in extinguishing an engine fire. Discharge of the bottles is controlled by the engine fire handles. The engine fire handles and APU fire handle are normally locked down and cannot be rotated. This feature protects from inadvertent engine shutdown and/or discharge of the bottles. When the detection system delivers an engine or APU fire signal, the associated handle solenoid is powered to unlock the handle. Therefore, when a fire signal is present, the associated handle is electrically unlocked and can be pulled. If the solenoid fails to unlock the fire handle, pushing the fire override switch below the handle manually unlocks the handle so that it may be pulled. Pulling and rotating an engine fire handle in one direction will discharge one bottle to the respective engine area, while handle rotation in the other direction will discharge the other bottle. There is one fire extinguisher bottle installed for extinguishing an APU fire. Rotating the APU fire switch in either direction discharges the fire extinguisher into the APU compartment. Fire protection for the forward, aft, and bulk cargo compartments consists of 2 cargo fire bottles. The first bottle discharges immediately into the selected compartment. The second bottle discharges at a later time or at a reduced rate into the selected compartment. Cargo fire bottles discharge in an automatic sequence to the selected compartment by use of switches on the cargo and APU fire panel. The lavatory has a single smoke detector. An oral enunciation, consisting of a horn, sounds in the lavatory when smoke is detected. Although the horn is audible in the immediate vicinity, there is no cockpit enunciation. Lavatory fire extinguishing consists of a small agent bottle below the sink area. This agent bottle will automatically suppress a fire in the waste container, but there is no cockpit enunciation of the extinguishing event. Fire suppression for the main cargo compartment is provided by a depressurization system. Activation of the depressurization system will shut off the air supply to the compartment so that the airplane gradually depressurizes and oxygen required for combustion is removed. When this system is active, the cabin altitude will rise up to the approximate flight altitude. There is no fire protection system for a wheel well fire. The procedure for a wheel well fire will direct the crew to extend the gear. This completes our introduction to fire detection and protection. Specific information is provided in the following CBT modules.
Components of the autopilot. The major components of the Autopilot Flight Director System, or AFDS, include the 3 Flight Control Computers, or FCCs, the Thrust Management Computer, or TMC, the Autothrottle System, 2 Flight Management Computers, or FMCs, and the Inertial Reference System, or IRS. The AFDS may be used to fly the airplane through pilot-selected direct control inputs from the mode control panel or through computer-generated inputs from the FMCs. The FMCs are capable of flying an optimized lateral and vertical flight path during climb, cruise, and descent by automatically managing pitch, roll, and thrust through inputs to the AFDS and autothrottle. The Thrust Management Computer provides autothrottle operation throughout the flight from takeoff to landing. Other supporting components include the Control Display Unit, or CDU, Electronic Flight Instrument System, or EFIS, and conventional flight instruments and radio navigation aids. The heart of the Autoflight system is a set of 3 Flight Control Computers, or FCCs. The FCCs combine flight director and autopilot operations and are identified as left, center, and right. The FCCs send flight director commands to the respective attitude director indicator, or ADI, and, with an autopilot selected to on or command, pitch and roll commands to the respective autopilot servos. The autopilot servos operate the flight controls through left, center, and right hydraulic systems. In most of the flight regime, the autopilot operates only the ailerons and elevators. Rudder control is only added during a multi-autopilot approach, in which case it also extends to provide nose-wheel steering during rollout from an automatic landing. The MCP contains the switches and controls used for the autopilot flight director commands and autothrottle operation. A light bar in the lower half of each switch illuminates when the switch is pushed to on to indicate that the mode has been requested. The actual mode status, active or armed, has to be determined by the indications of the flight mode enunciations, or FMA, of each ADI.
Autopilot engagement requested.
A light bar in the lower half of each switch illuminates when the switch is pushed to on to indicate that the mode has been requested. The actual mode status, active or armed, has to be determined by the indications of the flight mode enunciations, or FMA, of each ADI.
Autopilot engagement requires at least 2 functional FCCs and pushing one of the associated MCP autopilot engage switches. Only one autopilot is available in flight before autoland engagement. Thereafter, all 3 autopilots fly the airplane during the approach, landing, and rollout.
Anytime the autopilot disengages, either manually or automatically, the red autopilot disconnect light illuminates along with an ICAS warning message of autopilot disconnect and the sound of the siren going off. Normally, the autopilot is disengaged through the control wheel autopilot disengage switch. The autopilot disengage bar can also be used to disengage the autopilot or autopilots. All autopilot disconnect warnings can be deactivated by pushing the control wheel autopilot disconnect switch a second time. The Flight Director command bars are in view when the associated Flight Director switch is selected to on. The command bars will also display when the Flight Director switches are off if a go-around switch is selected to go around, when the airspeed is greater than 80 knots and the flaps are still extended. Flight Director failure in pitch or roll causes the respective command bar to disappear. Autopilot failures affecting the active mode are enunciated on the ADI. If the failure affects only the operating mode, pitch or roll, the autopilot remains engaged in an attitude stabilizing mode, but an amber line is drawn through the mode and the amber autopilot light on the forward instrument panel illuminates. Along with the light, an ICAS caution of autopilot is displayed.
Failures that result in degradation of all autopilot operational modes result in an automatic autopilot disconnect accompanied by an ARL warning. Depending on the system failure, it may be possible to re-engage an autopilot by pushing the autopilot engage switch. The Thrust Management Computer, or TMC, is the primary source of control of the autothrottle system. The TMC operates the autothrottle in response to manual mode requests from the MCP or to automatic inputs from the FMC as a function of VNAV.
The most important TMC functions are calculation of thrust limits, thrust settings in response to throttle commands or, in VNAV, to follow FMC thrust settings, actuation of the thrust levers, detection and enunciation of autothrottle failures. The autothrottle system provides thrust operation from takeoff through landing. Autothrottle thrust reference mode selections and selection of assumed temperature values can be made via the Thrust Mode Selector panel, or TMSP. Normally, autothrottle mode selections are made via the Mode Control panel. For instance, after takeoff, selection of flight level change causes the autothrottle to engage automatically in climb thrust. Thus, climb thrust does not have to be selected independently via the TMSP. In vertical navigation, or VNAV, the FMC selects autothrottle modes and target thrust values. The autothrottle can be used independent of the autopilot or flight director. The autothrottle can be manually overridden. The auto throttle can be disconnected with either throttle auto throttle disconnect switch or the auto throttle arm switch on the MCP.
Now using either disconnect method, the center instrument panel auto throttle disconnect amber light will illuminate, with ICAS presenting a caution message of auto throttle disconnect and the ARL beeper. Pressing the auto throttle disconnect switch on either thrust lever a second time will extinguish these lights and ICAS message, as well as cancel the ARL beeper.
Autoflight flight mode annunciations are provided in the ADIs. The FMAs display information from left to right pertaining to auto throttle operation, pitch, roll, AFDS status. Active modes are displayed in large green letters in the top part of the annunciator windows. Armed modes are indicated in smaller white letters underneath the green annunciations. Exceptions to these indications are takeoff on the ground and go-around in flight. Modes that become active when selected include flight level change, VNAV, N1, speed, heading hold, heading select, vertical speed, altitude hold. Modes that are normally armed before becoming active are LNAV, localizer, approach. In general, all modes can be canceled or disengaged by selecting another mode. LNAV, localizer, approach can also be canceled by pushing the mode switch a second time if the modes have not yet engaged. Now note, these are the modes that are normally armed before becoming active. You should know that after localizer and glide slope capture, the approach mode can only be canceled by disengaging the autopilot and turning both flight director switches off or selecting go-around. Two auto land status annunciators, or ASAs, are located on each pilot's instrument panel and provide information on the status of the AFDS to complete an automatic landing and rollout. Each ASA has an upper and lower annunciator display. Except during testing of the ASA, both annunciators show the same information. Monitoring of the Autoland status system begins with electrical system power-up. The possible displays in the ASAs are Land 3 in green. 3 autopilots have engaged and are operating normal for an automatic landing. The AFDS redundancy is at the highest level, also referred to as fail operational mode. Land 2, green. The AFDS redundancy is reduced. In some cases, only 2 autopilots are functioning. Fail passive mode. No land 3, amber, indicates a fault condition that results in diminished AFDS redundancy to make a land 3 automatic landing, but is good enough for a land 2 approach, landing, and rollout. No autoland, amber. The AFDS is unable to make an automatic landing. Below 200 feet radio altitude, the ASA display cannot change except to indicate a no autoland condition. An ICAS message is displayed for any fault limiting the capability of the automatic landing system. Should the fault clear prior to selecting the approach mode, the ASA will blank. The inertial reference system includes three inertial reference units, or IRUs. The terms IRU and IRS are used interchangeably. The IRUs provide different types of data for use by various systems. Attitude and heading are the most important types of data provided. Position, track, ground speed, wind direction and speed, and acceleration are additional data. Individual mode selectors are used to select and control each IRU. Two VOR DME panels can be manually tuned or auto-tuned by the FMCs to determine the airplane's position. ILS information is used by both the FMCs for FMC position and used by the FCCs for autopilot approaches and landing. VOR, DME, and ILS information can be displayed on the HSI. In addition to the Autoflight system MCP direct control inputs, the CDUs can be used to input to the Autoflight system via the CDU pages. The CDUs communicate with the FMCs, and the FMCs communicate with the FCCs through the Mode Control Panel LNAV and VNAV switches. In turn, the FMCs communicate with the pilot via the CDU scratchpad and CDU pages.
We now introduce the controls and indicators on the glare shield. A VOR DME panel with a course selector is located on each side of the MCP. The frequency select and auto manual switch are described in the VOR radio module. The course selector knob is used to select the VOR course, while the course indicator displays the selected course in a digital format. During manual VOR tuning, the selected VOR course is displayed on the appropriate modes of the HSI. Each rotational click of a course selector knob changes the respective course readout and course display on the HSI by 1 degree. The highlighted switches are alternate action type switch lights that are used to select modes. We will describe the operation of each alternate action switch with the appropriate mode description. When a switch is pressed, an illuminated bar appears in the switch, and the selected mode is either engaged or armed. Note: illuminated bar lights do not indicate the operating mode is functional. You must view the mode status on the FMA displays. All AFDS modes can normally be disengaged by selecting another command mode. In some cases, such as after capture of glide slope and localizer during the approach mode itself can only be disengaged by turning the autopilot and both flight directors off. We'll now give a brief overview of the specific controls on the MCP. This is only an introduction. The flight director toggle switches are used to enable the display of the command bars. Either flight director switch turned on will cause the FMAs to appear in both ADIs. The magnetic autothrottle switch is used to arm or disarm the autothrottles. When the autothrottle is armed, no actual autothrottle operation occurs until an autothrottle mode is engaged. The speed selector is used to adjust the selected speed for the MCP speed, flight level change, or VNAV speed intervention modes. The selected speed appears in the IAS Mach display when any of these modes are engaged. The Select push button allows for a changeover of the speed displayed from airspeed to Mach or vice versa. The heading selector allows the pilot to select a desired heading when the AFDS is operating in the heading select mode. The selected heading is displayed on the heading display. A bank limit selector is used to limit the roll guidance for the heading select mode. The bank limit selector has an auto position that limits the bank angle as a function of true airspeed. The heading hold switch can be pressed to engage the heading hold mode. This mode causes the aircraft to maintain the existing magnetic heading. If the aircraft is in a turn when this switch is pressed, the AFDS will guide to roll out to wings level and then maintain the heading. The vertical speed thumb wheel is used to select a climb or descent rate when the vertical speed mode is armed. The selected rate is displayed above the thumb wheel. The altitude selector is used to select a desired altitude. The selected altitude is displayed in the altitude display above the selector. The left, center, and right autopilot command switches are used to engage the respective autopilot in the command mode. Since normally only one autopilot can be engaged at a time, the engaged autopilot has to be manually disengaged before another autopilot can be engaged. We will now describe the various modes available on the MCP. The auto throttle N1 mode is used to set reference thrust for the various thrust modes. With the auto throttle armed, press the thrust switch to engage the mode. N1 displays on the FMA. The N1 mode sets power as calculated by the TMC and displayed on the ICAS N1 gauges. The N1 mode also controls thrust subject to the maximum speed limit. The available limits are reduced takeoff, takeoff, go around, reduced climb, climb, cruise, and continuous. The auto throttle speed mode is used to control the selected airspeed through auto throttle operation. With the auto throttle armed, press the speed switch to engage the speed mode. If the speed switch is pressed after takeoff above 400 feet RA, the thrust reference changes from takeoff to climb. If the selected speed is above an aircraft limit speed, the limit will be maintained. If the selected speed is below the aircraft performance for the current configuration, the performance speed will be maintained. More on speed limits later. The VNAV mode allows the FMC to control the vertical flight path and airspeed. Press the VNAV mode selector to engage the VNAV mode. Mode engagement requires that the required performance information and the cruise altitude have been entered to the FMS. With VNAV engaged, the AFDS and autothrottle follow thrust and speed commands from the FMC, the IAS Mach display blanks, and the airspeed cursors are driven to the FMC target speed. The crew can change the FMC target speed through the FMC CDUs or the MCP IAS Mach selector with speed intervention engaged. In VNAV Climb, the autothrottle sets FMC thrust, and the AFDS sets the FMC target speed using pitch. The MCP selected altitude constrains the VNAV altitude during climb or descent. For example, when VNAV is engaged, the aircraft will automatically level off at the altitude displayed in the MCP altitude display or the FMC altitude, whichever is reached first. Recall that proper MCP altitude selections ensure correct altitude alerting. During VNAV cruise, the AFDS will hold altitude and the autothrottle will set thrust to hold the FMC target speed. In VNAV descent, the auto throttle retards thrust to idle, and the AFDS holds the FMC target speed using pitch. The VNAV mode normally provides a path descent. In this condition, the AFDS tracks the FMC descent path using pitch, and the auto throttle will normally set idle thrust, but will increase thrust to maintain the FMC speed if the actual speed becomes too slow. VNAV can be disengaged by any of the following actions: selecting vertical speed, altitude hold, speed, N1, flight level change, glide slope capture, or selecting go around. The flight level change mode is used to climb or descend with a combination of automated thrust and pitch control to maintain the selected airspeed in the IAS Mach display. Flight level change is not an FMS mode. When engaged, the flight level change mode displays in the FMA as flight level change in the autothrottle window and speed in the pitch window. If the flight level change is pressed after takeoff above 400 feet RA, the thrust reference changes from takeoff to climb. If no active speed mode is displayed when the flight level change is selected, the present airspeed appears, and the airspeed cursors synchronize to allow the current speed to be the target flight level change speed. After engagement, the IAS Mach value can be changed by the use of the speed selector. With flight level change engaged, if a higher altitude is selected on the MCP altitude, the auto throttles advance thrust to the N1 limit, and the AFDS provides pitch guidance to hold the selected IAS Mach. With flight level change engaged, if a lower altitude is selected on the MCP altitude, the auto thrust sets idle thrust, and the AFDS provides pitch guidance to hold the selected IAS Mach during descent. The heading select mode is used to turn the aircraft to a specific heading as displayed in the heading window and the HSI heading marker. The commanded AFDS bank is restricted by the bank limit selector. Press the heading select switch to engage the mode. Heading select can be engaged prior to LNAV engagement or localizer capture. With heading select engaged, AFDS commands a turn in the same direction as the rotation of the heading selector. The heading window and heading marker initialize at 0 degrees upon aircraft electrical power-up. You should know that upon localizer capture, the heading bug and readout automatically display the selected ILS front course heading. The heading select mode will disengage if another roll mode is selected, except when on a heading to intercept an LNAV course with LNAV armed, or on a heading to intercept a localizer or back course with those modes armed. The purpose of the LNAV mode is to engage the navigation features of the FMC. With LNAV armed, the AFDS will capture and track the active FMC route. Recall the route is activated and modified through the use of the FMC CDUs. The FMC route can include SIDS, STARS, and instrument approaches.
For LNAV engagement, the aircraft must be above 50 feet radio altitude and within 2.5 nautical miles of the active leg. If not within 2.5 nautical miles of the active leg, the aircraft must be on an intercept heading to the active leg.
LNAV can be disengaged by selection of heading select or heading hold, or automatically when an armed localizer capture occurs.
Upon reaching the end of the active route, or when entering into a route discontinuity, LNAV will automatically revert to heading hold without a change in FMA display. This situation normally appears as a CDU scratchpad message. The vertical speed mode is used to climb or descend at specific vertical rates as selected by the vertical speed selector and displayed in the vertical speed window. Rolling the vertical speed thumb wheel towards up will command a climb, while rolling the thumb wheel towards down will command a descent. Note: the vertical speed mode is selectable when altitude hold is active at the MCP selected altitude. Vertical speed mode is inhibited after glide slope capture when the approach mode is engaged. The altitude hold mode is used to maintain altitude through AFDS commands. There are a few ways to engage the altitude hold mode. In either case, altitude hold displays in the FMAs when the mode is active. First, altitude hold may be engaged by pressing the altitude hold switch. In this case, the AFDS commands to hold the altitude that existed when the switch was pressed and the bar light in the switch illuminated. Another way to engage altitude hold is by arrival at the MCP selected altitude. This situation will first cause the altitude capture mode to engage, followed by altitude hold when the aircraft is on the selected altitude. The MCP selected altitude is referenced to the captain's barometric altimeter setting for the left and center autopilots and flight directors. The MCP selected altitude is referenced to the first officer's barometric altimeter setting for the right autopilot and flight director. After engagement of altitude hold, changes in barometric settings don't affect the selected altitude reference. Selecting another pitch mode disengages altitude hold. The localizer mode is used to arm the ILS localizer for intercept and track. With the localizer frequency tuned on the ILS panel, press the localizer switch to arm the mode. The AFDS will intercept the selected localizer course from the heading select mode or LNAV mode. Capture of the localizer course varies as a function of the closure rate and the actual intercept angle, which can be as large as 120 degrees. When the localizer is captured, the AFDS will command up to 30 degrees of bank, regardless of the MCP bank angle selector. The localizer mode is a single autopilot function. Multiple autopilots cannot be engaged in localizer. The approach mode is used to capture and track an ILS during approach, landing, and rollout. With the ILS frequency tuned on the ILS panel, press the approach switch to arm the approach mode. The localizer must be captured before glide slope capture can occur. The AFDS captures the glide slope at less than 1 dot displacement, then commands a descent rate to track the glide slope signal. If the ILS transmitter fails, the airplane continues on inertial track. After a short delay, an amber line is drawn through the affected FMA enunciation, glide slope or localizer, and the affected flight director commands are removed from view. The approach mode remains engaged until a go-around switch is pressed, or the autopilots are disengaged and both flight directors are turned off.